Hey guys, today I'm doing the K method. The reason that I think it's important for all grade 12s to watch this video is because sometimes you think you understand the K method and you don't really, which is what happened to me in my paper 2 trial exam. The K method popped up in trigonometry general solution, and because I didn't realize that the K method isn't something that only appears in algebra, I didn't realize that I could have used the K method. Well, I knew I had to use the K method. I just didn't know how to use the K method in that situation because I hadn't been exposed to a situation like that before. So that is why I'm making this video. It is important. Even if you think you know the K method, please go over this. Okay, so the first example that I used over here is a super easy example. It's for people who don't know how to use K method at all and are absolutely clueless. If you do know how to use the K method in general, please skip the first example. Okay, so I first did it the conventional way, so that you can compare for those who don't know how to do the K method. Oh, and what is the K method? Sorry. The K method is where you substitute a common missing variable in your equation. So it's a missing variable that appears more than once in your equation. You substitute that with a letter, which is traditionally K because we're using the K method, to make your equation easier to work with. And at the very end, you get an answer for K and you substitute that missing variable back in the place of K. Okay, so in this example, the traditional way would just be to take out what is common, which is 2 to the power of x, which means we're going to be left with 2 to the power of 2 plus 1 in our brackets, which simplifies to 5. Divide by 5 on both sides, which means we'll have 4 on the right-hand side. And then, remember, you cannot equate a missing variable that's an exponent unless bases are the same. So I can't just say something like x is equal to 4 or whatever it is. You can't do that because you need to make sure that the bases are the same. This is the base, sorry, in case you forgot what a base was. This is the base. This over here is the exponent. So you need to make sure that the bases are the same. And once the bases are the same, you can equate the exponents. So that's what I did over there. Let's try and do it with the K method. So the common missing variable over here is 2 to the power of x, as you can see. So you must say, and this is important, people often forget to say this. They just start using K randomly, but they never said, let the missing variable equal K. And you can lose marks for that because you can't just start randomly using your own stuff. You have to explain why you're doing it. So we say, let the missing variable equal to K, and then the next thing that I want you to do is to simplify all of your exponents. For example, if you don't simplify this, what can happen is you're going to say, oh, 2 to the power of x is k, and then I have a 2 left over, so it's k squared plus k is equal to 2. That's wrong. And the reason it's wrong is because this over here is actually 2 to the power of x times 2 to the power of 2. So if this is going to become k, then it's actually k multiplied by 2 to the power of 2. So it's actually 4k. So that's why one thing I recommend about the K method is before you do anything, simplify your exponents. So you should actually do this before you say let 2 to the power of x equal k. But anyway, simplify all of your exponents. And another thing I like to do is all the numbers that appear in my equation, I see if I can make them all the same base. Like here I have 20, so I'd ask myself, can I make 20 a base of 2? Like, can 2 to the power of something give me 20? And it can't, at least not a whole number. It would be some weird decimal. So then I ignore it. But if it can be simplified to be the same base as the bases in the rest of the equation, please do that because sometimes you need to for K method. Okay, so then it's going to become 4k plus k is equal to 20. So 5k is equal to 20. Divide by 5 on both sides. K is equal to 4. You can't stop here. I've actually seen people stopping at the step, which you can't do because you didn't answer the question. The question was to simplify 2 to the power of x, or to simplify x, and you haven't done that. So you need to substitute back. 2 to the power of x is equal to 4. So 2 to the power of x is equal to 2 to the power of 2. Because bases are the same, I can equate the exponents. Therefore, x is equal to 2. This is a super basic example. Let's go on to the more difficult one. Okay, so in examples like this, you could take 3 to the power of x out as common and just factorize as normal, but it becomes very messy and difficult and you can make mistakes. It's much easier to just use K method. So over here, you're going to see what the missing variable is, and you guessed it, the missing variable is 3 to the power of x. You can't use 3 to the power of 2x and 3 to the power of x. It has to be the same missing variable throughout. So it's 3 to the power of x. So first, before I say let 3 to the power of x equal k, I'm going to simplify all of my exponents. So this is going to become 3 to the power of x multiplied by 3 to the power of x minus 8 times 3 to the power of x minus, and now I have a 9 over here, so I'm going to ask myself, can I make 9 a base of 3? And I can make it 3 to the power of 2. Sometimes this is not necessary and it has a net effect of 0 in your equation and it doesn't help, but it's always good to do it just in case, because sometimes you do need it. So rather just simplify it. And 8, I can't make it a base of 3 in any way. 3 to the power of, I can't get 3 to the power of anything that will give me 8. It'll be some weird decimal. So that's why I left that. Then I say let 3 to the power of x equal k. Therefore, k squared, because it's k times k, minus 8k minus 9 is equal to 0. See, that 3 to the power of 2, it didn't do anything. We could have just left it, but just simplify in case. Now we have a trinomial. So I'm going to say, okay, the last term is 9. Now what factors of this term, when added or subtracted, will give me the middle term? So the factors of 9 are 3 times 3 and 9 times 1. Now when I add or subtract 3 and 3, if I say 3 plus 3, I'm getting 6, so I can't use that. If I say 3 minus 3, I'm getting 0, so I definitely can't use those two. If I say 9 minus 1, I'm getting positive 8, so that's not right. But if I say minus 9 plus 1, or 1 minus 9, then I will get minus 8, so I know I have to use this. Gave you some quick revision on grouping there. So this would be plus 1k minus 9k, because minus 9 plus 1 is minus 8, is equal to 0. Take out what is common, and you should be left with this. Therefore, k plus 1 is equal to 0, or k minus 9 is equal to 0. Therefore, k is equal to minus 1, or k is equal to 9. But don't stop here. You haven't answered the question. Substitute 3 to the power of x back. So 3 to the power of x is equal to 1. This would be a no solution because it's giving you a negative on the one side, and also, yeah, you can see that you can't get a solution for that. Here, we're going to substitute back 3 to the power of x is equal to 9. Now, we need to make 9 a base of 3 because bases have to be the same in order to equate the exponents. So 3 to the power of x is equal to 3 to the power of 2. Therefore, x is equal to 2. Now, you can always go and substitute 2 back into this original equation and see if it gives you 0. Then you know if you've done it correctly. Okay. Now, the last question, this is the hardest one. I saw this question in my trial paper 2 exam. It was the 2020 September paper 2. You can find it on the Stanmore site if you want, the KZN paper. And it was where you had to use the K method in a general solution. So the question was 3 to the power of 2 tan x minus 3 to the power of tan x plus 1 is equal to 54. Feel free to pause the video and try and attempt it yourself. But remember, you're not just solving for tan x, you need to do general solution as well. So feel free to pause the video and attempt it yourself. Okay, so now I'm going to try and show you how to do this the traditional way versus K method, so that you can see that this would be a clear situation where you have to use the K method. So if I try to do this the normal way, first let's simplify exponents. 3 to the power of tan x times 3 to the power of tan x minus 3 to the power of tan x times 3 to the power of 1 is equal to 54. Now, obviously, I'm going to take 3 to the power of tan x out as common. And the reason I checked if 54 could be made into a base of 3, but I got 2 times 3 to the power of 3. So the reason I didn't change it was because it's not just giving me a base of 3 on its own, it's being multiplied to something else, so I just left it. Okay, so 3 to the power of tan x is what is common, so I'm taking out that as being common. 3 to the power of tan x. Oof, what did I even do? Don't make the mistake of putting 3 to the power of 2 over here, because then you're saying 3 to the power of tan x plus 2, and you want 2 tan x. So you actually are going to put 3 to the power of tan x here, because when you add the exponents, you'll get 2 tan x. Minus 1 is equal to 54. Therefore, 3 to the power of tan x is equal to 54, or 3 to the power of tan x is equal to... wait a second. I didn't do something right. I did not do something right. This is supposed to be 3. My bad. If it was 1, then I'd be saying 3 to the power of 2 tan x minus 3 to the power of tan x, which is wrong. It should have been 3 to the power of tan x plus 1. So that's actually a 3 over there. So then this would be 3 to the power of tan x is equal to 54 plus 3, which is 3 to the power of tan x is equal to 57. Now, this is when you would realize you have to use the K method, because this shit is unfactorizable, okay? If you change this, you'll say 3 to the power of tan x is equal to 2 times 3 to the power of 3. Now, what are you going to do at this point? Because it's being multiplied by something. So you can't make the exponents equal, because you have a 2 there now. So what are you going to do? And then over here, if you say 57, if you try and get 57, you're going to have 3 times 19. And 19, if you try and get that to be smaller, it doesn't, because it's a prime number. So over here, we have 3 to the power of tan x is equal to 19 times, what is it? Sorry. 57. Oh, it's 19 times 3, right? Yeah, no, this doesn't work, man. It doesn't work. And that is when you would realize, okay, I have to use the K method. So let me show you how to use the K method here. This was a bit weird, because a trig identity was actually part of your missing variable, which is strange, right? Because usually you're just solving for like a 3 to the power of x or 3 to the power of y, not having like tan or sine or cos in the thing you're taking out. But just remember that it can be that way. So you're going to say let 3 to the power of tan x equal k. So it's going to be 3 to the power of tan x multiplied 3 to the power of tan x, minus 3 to the power of tan x times 3 is equal to 54. Okay, cool. So now we have k squared is minus 3k. See, the reason I like you to write it out is because if you had just done it straight from here, you might get tempted to just say k to the power of 1. It happens. Okay, minus 3k is equal to 54. Now you have a trinomial. Minus 54. Factors of 54, when added or subtracted, that will give me 3, is 6 and 9. Wait, let's double check that. 6 times 9, yeah, gives me 54. So if I say minus 9 plus 6, I'll get minus 3. So I'm going to say k squared minus 9k plus 6k minus 54 is equal to 0. Then we just do normal factorization. Plus 6k minus 9 is equal to 0. I accidentally ended my last video, but anyway, I just started a new one. Okay, so then it's going to be k is equal to... I'm actually shortcutting one step. Please do the whole thing in your exam. I just don't have space. Or k is equal to minus 6. Now, substitute back. It is not over. So 3 to the power of tan x is equal to 9, or 3 to the power of tan x is equal to minus 6, which is no solution, because I don't know how you would be able to solve that. Then 3 to the power of tan x is equal to 3 to the power of 2. bases are the same, so you can equate the exponents. Therefore, tan x is equal to 2. And from here, you do general solution. You're not done. That's why it was like 6 marks. So you have to do general solution after this. But this was a really interesting way of just reminding yourself that K method can be used anywhere. And when you are in a situation where nothing is working, just ask yourself, is there a common missing variable? And if there is, that's an indication that you should use K method. Okay, guys, good luck for your exam. Don't fail. And if this video is helpful, like it. If it wasn't, tell me why it wasn't and give me advice on how to make my future videos better. Bye, guys.